Hello everyone, good afternoon. Good afternoon. So I think I'm audible, right? Yes. So we are in 15th lecture of ODE. I think I'm audible. Yes. So we are in 15th lecture of ODE. So from lecture number 1 to lecture number 13, we have been solving problems based on differential equations of first order and first degree, right? So there are many methods to solve a differential equations of first order and first degree. So we have solved lecture number 1 to lecture number 13 problems based on that, right? The last class, right, in lecture number 14, just a minute. Yes, the last class, what it is, we have started second topic, right? Second topic, which is a second and higher order linear differential equations with constant coefficients, right? This is what we started in the previous class. So if you haven't watched all the previous videos, go through all the previous videos, right? Okay, so we will just recall what we did in the previous class, right? This is the notes of previous class. So you can see we have started defining what is meant by a linear differential equations with a constant coefficient, right? So you can see if you have an equation of the form a naught dn y by dxn plus a n dn minus 1 by dxn minus 1 and so on up to a and y is equal to x. This x is a function of x, right? This is called a linear differential equation with the constant coefficients. This a naught, a1, a2, an are all constants. It is called a linear differential equations, right? Of nth order, right? Of nth order. So usually, what I said in the previous classes, in exam point of view, they will have second order, third order, or fourth order. So what is how the second order equation will be? It will be of this form, right? Second order means a naught d square by dx square plus a dy by dx plus a2y is equal to x, right? This is third order linear differential equation constant coefficient. This is what is in the previous class. Remember, this x is very important, right? Now, what is the solution of this equation? The solution of this equation is given by y is equal to complementary function plus particular integral, right? The general solution of this equation, this linear differential equation with the constant coefficients is given by complementary function with particular integral, right? The method of finding the complementary function is same. Whatever this x may be, right? Whatever the RHS x may be, the method of finding the complementary function is same for all, right? And depending upon the x, the particular integral will vary. The method of finding particular integral will vary. We discussed in the previous class, right? Now I have said that whatever the capital X RHS may be, the method of finding complementary function is same. How to find complementary function? We have discussed in the previous class, right? So first, what you have to do is you need to find the auxiliary equation. You need to find the auxiliary equation. So remember, this capital D is same as d by dx, right? So this equation can also be written as a naught d power n plus a n dn minus 1 and so on up to a n of y is equal to capital X, right? This is a recall of previous class, right? So in this equation, you have to replace d by m and equate this term to 0. So you will have a polynomial of degree n. So you find the roots of auxiliary equation. Depending upon the nature of roots, I have given you the formula for characteristic functions, right? If you have two real and distinct roots, your characteristic function is c1 e power m1x plus c2 e power m2x, right? I have given you all these formulas. And then we move on to type 0. What is type 0 is RHS is 0, right? What I have said, complementary function is same for all, whatever x may be. The complementary function is the method of finding complementary function is same for all, right? Now, depending upon the values of this x, we need to find particular integral, right? Okay. Now type 1. So what is type 1 is RHS is 0. That is your x is 0. Your x is 0, then this equation will be it will be like this term is equal to 0. In that case, the solution is given by CF alone. You don't need to add PI, right? Usually solution is y is equal to complementary function plus particular integral. So CF, I'm going to say CF from now on. CF means complementary function. PA means particular integral, right? So when your RHS is 0, the solution is given by y is equal to CF alone, right? So we have solved almost 10 to 12 problems based on this. So the first question is d square by dx square minus 3 times dy by dx minus 4y is equal to 0. So this can be written as d square minus 3d minus 4 of y is equal to 0. You find the auxiliary equation, replace this capital D by m, So you will have m square minus 3m minus 4. Find the roots. You are getting two distinct real roots. If you have two distinct real root means the characteristic function is c1 e power m1x plus c2 e power m2x. So here m1 and m2 are 4 and minus 1. Substitute back here. Right? This is a solution also. This is what we discussed in the previous class, right? Now in this class, we're going to move on to type 1 and type 2, right? I had to complete type 1 and type 2 in this class. If not, we'll complete type 1 in this class, right? So type 1 is RHS is e power ax, right? Type 2, sorry, type 1. So type 1 is, type 0 is RHS is 0. RHS is 0 is type 1. Now type 1 is, type 0 is RHS is 0. Type 1 is RHS is e power ax, right? RHS is e power ax. Okay, so we'll start type 1. RHS is e power ax, right? So that is your capital X will be of the form e power ax. E power ax. And this a is a real number. A can be any real number, right? A can be any real number. So how to solve this, right? How to solve this? That is it will be of the form a naught dny by, let us take a nth order linear differential equation constant coefficient, right? Let us take the nth order linear differential equation with constant coefficient, right? And so on up to an of y is equal to, we will have capital X. Instead of capital X, I'm going to put e power ax, right? Because your RHS is e power ax, right? Okay. So the solution is given by y is equal to complementary function plus particular integral. The method of finding complementary function is same, right? Whatever it in the previous case, right? That is, we have to, okay, this can be written as, so this one can be written as a naught d power n plus an d power n minus 1 and so on up to an of y is equal to e power ax, right? Is equal to e power x, right? Super. Now the solution is y is equal to cf plus pi. The method of finding cf is same, right? The method of finding cf is same as type 0, right? That is, you have to, that is find auxiliary equation, right, and equate to 0. What is auxiliary equation? It is a naught m power n plus an m power n minus 1 and so on up to n is equal to 0. So depending upon the nature of roots, find characteristic function, right? So depending on nature of roots, find characteristic function. This is same as the previous case. Now in the previous case we have 0 in the RHS. So therefore for the previous case the solution is y is equal to cf, right? But if you have some other term, if you have non-zero x, right, solution is y is equal to cf plus pi. Now how to find pi? This is what the very important thing, right? So to find pi, right? Now let us call this as function of d, right? Let us call this as function of d, right? I don't want to write all, I don't want to write this lengthy term, right? I'm going to denote this as f of d. This is a function of d, right? Now to find pi, the pi is given by 1 divided by f of d into e power ax, right? The pi is given by 1 divided by f of d into e power x. What is f of d? F of d is this the question, right? This a naught d power n plus a1 d power n minus 1 and so on up to an of y is equal to e power x. This is our f of d, right? So after writing this, you have to replace d by a, right? So you have to replace this d by a. So no, is it clear, right? Up to, so you just write 1 divided by the given question into e power ax, right? Whatever the question name, it can be e power 2x, it can be e power 3x, it can be e power minus x, a can be anything, right? Now you have to replace d by a. So therefore this will be 1 divided by f of a into e power ax, right? If f of a is not equal to 0, right? If f of a is not equal to 0, let us call this as capital A, right? If f of a is not equal to 0, then A is the required particular integral. A is the required particular integral. This is the procedure for type 1, right? If f of a is not equal to 0, then this is the particular integral, right? Okay. Now, maximum I try to complete within this month, right, Sarah? Maximum surely I'll complete in this month, maybe in 20th or 25th, right, like that. If f of a is not equal to 0, then this is the particular integral, right? To join Telegram group, you will have more updates. If f of a is equal to 0, that is after substituting d to be equal to a, find the value of f of a. If f of a is not equal to 0, then this is the particular integral. If f of a is 0, right? If f of a is equal to 0, what you have to do is, sir, a comes, this is a. I'm just marking this as a. Okay, let us call this as 2, right? I don't want to confuse this. Let's call this as equation number 2, because I already used 1 here. Then 2 is the required particular integral, right? If f of a is equal to 0, what you have to do is, right, if f of a is equal to 0, then your particular integral will be multiply x, right, multiply x and differentiate the f of t. Differentiate f of d, right, differentiate f of t, right? What you have to do, if the denominator is 0, multiply 1x, right, multiply 1x, that is multiply 1x and differentiate the denominator. Differentiate the denominator. This is your denominator, right? F of d. Okay. Now again, put d to be equal to a. Right? Put d to be equal to a. Again, put d to be equal to a. Then what will be your pi? X divided by 1 divided by f dash of a into e power ax. Right? If, let's call this as 3, right? If f dash of a is not equal to 0, then this 3 is the required particular integral, right? Then 3 is the required particular integral. If f dash of a is again 0, right? What you have to do? Yes, this f dash of a. That is, if this denominator is non-zero, right? If f dash of a is not equal to 0, then this is the required particular integral. If f dash of a is equal to 0, what do you have to do? What do you have to do? If f of a is equal to 0, now particular integral will be multiply x again, so you will have x square divided by f double dash of d into e power x. You again have differentiate the denominator. You multiply 1x again, already we have 1x, multiply 1x again, so we will have x square, right? X square, and differentiate the denominator once again. Remember, you should not touch this, right? Only thing is you are differentiating the denominator, not this part, right? Not this part. Okay. Now again, replace d is equal to a. Again, replace d is equal to a, right? Let us call this as equation number 4, right? If f, again you put replace d is equal to a. If f double dash of a is not equal to 0, then 4 is the required particular integral, right? 4 is the required particular integral, right? If f double dash of a is equal to 0, then what you have to do? Repeat the procedure. I don't want to say again, right? Repeat the procedure until the denominator is non-zero. That is, this should be non-zero. This is the procedure. That's it. If you understand this single slide, then you can do any problem in type 1. Right? Is it clear up to now? The only thing is PA is you need to start from here, right? 1 by f of d e power x. You put d is equal to a. If this is non-zero, means problem is over. Suppose if 0 means multiply x and difference the denominator. Again put d is equal to a. If it is non-zero, means that is a solution. That is a required particular integral. Again, if 0 means multiply x again, difference the denominator once again. Again you put d is equal to a. If it is 0 means again you multiply x again and divide the denominator until you get the non-zero denominator. Is this slide is clear? If this slide is clear, then we can do any problem on type 1. Right? Very, very easy problem. The only thing is you have to understand this slide and then one or two problems, then problem will be very easy for you. Right? Okay, so we'll do some problems. So we'll do some problems and then I'll give some exercise problems. After that, we'll move on to type 2. Right? Okay. So solve d square y by dx square minus 3 times dy by dx plus 2y is equal to e power 5x. Now you can this comes under what? It is a linear differential equation. It is a linear differential equation of second order with constant coefficient. E raised to 0 is 1, so denominator is not 0. See, denominator is f of d, not e power ax. This is your f of d, right? Your f of d is this term, a naught d power n, a1 d power n minus 1. I'll do one problem, we'll have more clarity, right? Okay. We are not even differentiating this e power x. The only thing is we are differentiating this f of d. This f of d is this term. We'll do we'll do one problem then, and then we will have clarity. So this can be written as d square minus 3d plus 2 of y is equal to e power 5x, right? So the solution is given by, the general solution is given by y is equal to complementary function plus particular integral, right? So we will find CF, right? So we will find CF, right? Okay. To find CF, the method of finding CF is same for previous case, right? So you just find the auxiliary equation. What's auxiliary equation? M square minus 3m plus 2 is equal to 0, right? Okay. So solve this equation. So you will have m to be equal to minus b plus or minus square root of b square minus 4ac divided by 2 times a. So you will have 3 plus or minus square root of 1 by 2. So 3 plus 1 by 2 is 4 by 2. 4 by 2 is 2. 3 minus 1 by 2 is 2 by 2, which is 1. That means the roots are real and distinct. Roots are real and distinct. So therefore, what is your characteristic function? C1 e power m1x plus C2 e power m2x will be C1 e power 2x plus C2 e power 1 into x. This is your characteristic function, right? Remember, we come to the main part. Now, what is particular integral? 1 divided by f of d. This is your f of d now, which is d square minus 3d plus 2 e power 5x, right? This is your f of d now. F of d is this term, right? Remember, here I have taken this as f of d, right? Now, what you have to do? Replace d to be equal to a. Now, what is a here? E power ax. So, a is 5. So, replace d to be equal to 5. So, this will be 5 square. We are not keeping, we should not test this, right? The only thing that we have to get from this data is replace d by a. So 5 square minus 3 into 5 plus 2 e power 5x. Sorry. So this will be 1 divided by 25 minus 15 plus 2 into e power 5x. So 25 minus 10, 15 is 10, 10 plus 2 is 12. This is non-zero, right? This is non-zero. That means this is the required particular integral. If it is 0 means we have to multiply x, differentiate this denominator. It will be 2d minus 3. But here we don't need to do that because the denominator is non-zero. So therefore this is a required particular integral. Therefore the solution is, general solution is d is equal to cf plus pi. So cf is c1 e power x. Sara, is it clear now? c2 e power x plus pi. So 1 by 12 e power 5x. See, I have taken the general procedure here, right? The general procedure here. Basil, is it clear? See, the previous problem, if it RHS is 0 means we will stop here itself, right? That is, we will find only CF. But if we are in type 1, RHS is e power ax. In that case, there will be pi. So to find pi, it will be 1 divided by f of d, right? F of d into e power ax, replace d by a. So the 3 plus d by a. If this denominator is non-zero, that is the required particular integral. If this is 0 means you have to multiply one x here, differentiate this with respect to d, and then you put again d is equal to a. Right? Okay. This is the required solution. So we want a second problem. Solve d square y by dx square minus 5 times dy by dx plus 6y is equal to e power 4x. Right? This is a linear differential equation with constant coefficients, right? Because you can say the coefficients are constants, right? Therefore, this is same as d square minus 5d plus 6 of y is equal to e power 4x, right? So therefore, the general solution is given by y is equal to complementary function plus particular integral, right? That is what it means is you find C1 and C2. Here there is no any data to find C1 C2, right? If they give some initial condition means we can find C1 C2. That is, this is a required function that satisfies this equation. That is, if we put y to be equal to this function and we substitute back here, you differentiate this y 2 times minus 3 times, you differentiate this function with respect to x once and multiply 2 times this term and add it up, you will get e power 5x. Solution means part. This is the required function that satisfies this condition, right? Equation. Okay. Now what is CF? So to find CF, the previous class itself we have solved many problems so that you will have some very good knowledge about how to find CF, right? So what is the auxiliary equation? So it is m square minus 5m plus 6 is equal to 0. So the roots are minus b plus or minus root of b square minus 4ac divided by 2 times a. So this will be 5 plus or minus 1 by 2, right? 25 minus 24 is 1. So 5 plus 1 by 2 is 6 by 2 is 3, 4 by 2 is 2. So again you can say roots are real and distinct. Therefore, a complementary function is c1 e power 2x plus c2 e power 3x, right? Now to find pi, to find particular integral, so particular integral is 1 divided by f of d. So d square minus 5d plus 6 into e power 4x. Now replace d by a. Replace on d by a. So d by a is 4 here. It will be 1 divided by 4 square minus 5 into 4 plus 6 into e power 4x. So 1 divided by 16 minus 20 plus 6 into e power 4x. So 16 minus 20 is minus 4. 6 minus 4 is 2. So 1 by 2 e power 4x. This is non-zero. That means this is the required particular integral. So therefore, the solution is y is equal to cf plus pi. So cf is c1 e power 2x, c2 e power 3x plus 1 by 2 e power 4x. Is it clear? Okay, so we'll move on to third problem. Solve d cube y by dx cube plus y is equal to 3 plus 5 into e power x, right? 3 plus 5 into e power x. See, if you have constant term, you can always write that as p into e power 0, right? In that case, your e power ax, right? E power 0x. You can always write like this, constant. If you have constant term, you can always write like this, right? So constant term also falls under this case only, right? Okay, so we'll do this. So first is so this is same as p cube plus 1 of y is equal to 3 plus 5 e power x, right? So therefore, the general solution is given by y is equal to cf plus pi1 plus pi2. So you will have two terms here, right? So you find pi particular integral for this term and you find particular integral for this term and add it up. This is a required solution, right? Now to find a cf, so we have what is the auxiliary equation? M cube plus 1 is equal to 0. So what is a cube plus b cube? So a plus b, a square minus ab plus b square is equal to 0, right? A cube plus B cube is A plus B, A square minus AB plus B square, right? Therefore, clearly you can see M is equal to 1 is 1 root. So M is equal to minus 1 is 1 root, right? M is equal to minus 1 is 1 root. The other two roots are factorize or solve this equation. So you will have M is equal to minus B plus or minus root of B square minus 4AC divided by 2 times A. So 1 plus or minus, this is root minus 3, right? Same as I root 3. So you will have minus 3 here. So I can write minus 3 as I square into 3. So take that I square outside. So you will have I into root 3 by 2. So you can see one distinct root and one para complex root, right? We have one distinct root and one para complex root. This is 1 by 2 plus or minus I root 3 by 2, right? So this is alpha plus or minus I beta. So therefore, the characteristic function is C1 e power m1x, this distinct root, plus we have a complex root, right? So we will have e power alpha x, C2 cos beta x plus C3 sin beta x, right? I have already listed out all the formulas in the previous class itself. So C1 e power minus x, e power alpha x into C2 cos beta x plus C3 sin beta x. This is the required PF, right? Now we will find PI1. What is PI1? 1 divided by f of d into 3, right? This is your RHS for PI. This I can write this as e power 0x, right? So replace d by a. So here a is 0, right? E power ax, a is 0. This will be 1 divided by, so take this 3 outside, right? Take this 3 outside. So 1 divided by 0 plus 1 into e power 0x. So that means this is non-zero. So 1 by 3 is the PI1 value. Now you find PI2. So 1 divided by f of d into 5 e power x, right? 5 e power x. Now again you replace d by a. So here a value is 1 e power ax. So 5, take that outside. So it will be 1 plus 1 e power x. So you will have 5 by 2 e power x is your PI2. Therefore, the general solution is y is equal to complementary function plus PI1 plus PI2. So you just add it up all this, right? So this term plus 1 by 3 plus 5 by 2 e power x. Is it clear? Any more? The next problem. A minute. Take some more problems. Just a minute. Outside there is some work going on. I think there will be some noise in the video. Please adjust it. Yes. So just a minute. solve. Is it clear up to now? Ah, yes, thank you. I did see 3 only. Okay. So 3 plus 5 by 2 e power x square px, right? So I'm on the fourth problem. So solve 4 times d square dy by dx square minus 12 times dy by dx uh, plus 9y is equal to 144 e power 3x by 2, right? E power 3x by 2. Okay, so we'll solve this quickly. This is same as 4 times d square minus 12 times d plus 9 times y is equal to 144 e power 3x by 2, right? So what is solution? The solution is given by y is equal to complementary function plus pi, right? We have only one term here. So therefore, first we will find complementary function, right? So what is complementary function? First you find the auxiliary equation. This 4m square minus 12m plus 9 is equal to 0, right? 4m square minus 12m plus 9 is equal to 0. Solve for this. M is equal to minus b plus or minus root of b square minus 4 times ac divided by 2 times a, right? So this will be 12 plus or minus square root of, so 16 199, so it will be 0 divided by 8. So this will be 3 by 2, right? So 3 by 2 plus 0, 3 by 2 minus 0. So therefore the roots are real and equal. Roots are real and equal. So in that case, your CF will be C1 plus C2x, C1 plus C2x into e power mx. So here equal root is 3 by 2, right? This is your characteristic function. Now to find pi, so what is pi? So 1 divided by f of d. So f of d is 4d square minus 12d plus 9 into e power 3x by 2, right? So replace d by a, e power ax, right? A is 3 by 2. So no, e power ax, replace d by a is 3 by 2. So this will be 1 divided by 4 into 3 by 2 whole square, 12 into 3 by 2 plus 9, right? Plus 9 into e power 3x by 2. So this will be, so 2 square will get cancelled, right? This will get cancelled. You will have 9, right? Here you will have 9. So this will be 2 1s are 2 6 are, and here we will have 2 square is 4. 4 will get cancelled. So we have only 9. So 9 minus 18 plus 9 e power 3x by 2. Now you can see denominator is 0, right? 9 plus 9 is 18. 18 minus 18 is 0, right? So denominator is 0, right? What you have to do, multiply x, differentiate the denominator, right? F of t, f dash of t. So it will be 8d minus 12, right? E power 3x by 2. This step is clear. So if this denominator is 0, multiply x and differentiate this denominator with respect to d. Now again you put d is equal to 3 by 2, right? You should not touch this, right? Only thing is you are differentiating this denominator. Again you put d is equal to 3 by 2. This will be x into 1 divided by 8 into 3 by 2 minus 12 e power 3x by 2, right? So this is equal to x into 1 divided by so 2 1s are 2 4s are. So again you can see 12 minus 12 e power 3x by 2. Again what? Denominator is 0. That means what? To multiply x once again, differentiate the denominator once again. F double dash of t. This is your f dash of t, right? So 8d differentiation is what? 8. So into e power 3x by 2. Now you don't even have to replace d by a because there is no a here and d here, and also this is non-zero. This is the required particular integral. So x square by 8 into e power 3x by 2 is the particular integral. Is it clear? Yeah, I'm differentiating once again, right? If whenever I put denominator is 0, the next step will be I'm multiplying x and differentiating denominator. You have to differentiate this term, right? And let's call this as 2. Differentiate 2. Differentiate, because we should have f double dash of d, right? Already we have found f dash of t. So differentiate that once again, you will have f double dash of t. This is the particular integral. So therefore, general solution is y is equal to complementary function plus particular integral. So c1 plus c2x e power 3x by 2 plus x square by 8 e power 3x by 2 is the required solution. Is it clear? Is it clear? And what next problem? Okay. On fifth problem, solve d square plus 4d plus 4 of y is equal to 2 times sin h2x, right? Sin h2x, right? So what is sin h ax? This is same as 2 into sin h ax, right? It is e power 2x minus e power minus 2x by 2, right? Sin h ax, e power ax minus e power minus ax divided by 2, right? Similarly, cos h ax is e power ax plus e power minus ax by 2, right? Okay. So this is same as I can cancel these two. So you will have e power 2x minus e power minus 2x, right? So let us call this as pi1, call this as pi2, right? Therefore, the general solution is given by y is equal to cf plus pi1 plus pi2, right? So to find cf, so what is the auxiliary equation? So it is m square plus 4m plus 4 is equal to 0. So solve this, m is equal to minus b plus or minus root of b square minus 4 times ac divided by 2 times a. So this will be 0, right? So minus 4 plus or minus 0 by 2. So 2 2s are 2. So minus 2 is the, you have two equal roots, right? So minus 2 is your um, roots. So therefore, the roots are real and equal. The characteristic function will be c1 plus c2x into e power minus 2x, right? Okay. Now we will find pi1. So pi1 is 1 divided by, actually, let's write this as minus pi2 because you have minus here, right? So that we will take only pi2 to be equal to e power minus 2x, right? Let's write this as minus. So 1 divided by d square plus 4d plus 4 e power 2x, right? E power 2x is your pi1. Okay. Now replace d by 2, right? So 1 divided by 2 square is 4. This will be 8. This will be 4 e power 2x. So this will be 1 by 16 e power 2x, which is non-zero. Therefore, this is the required pi1. Now you find pi2. So 1 divided by d square plus 4d plus 4 f of d e power minus 2x, right? For pi2, it is e power minus 2x. Now replace d to be equal to minus 2. This will be 1 divided by minus 2 square is plus 4. It will be minus 8 plus 4 e power minus 2x, right? This is 0. This is 0. So it is 0, right? This is 0. So we will have 1 by 0 into e power minus 2x. In that case, what you have to do? Multiply x, difference in the denominator. So d square is 2d plus 4d is 4 e power minus 2x. Now replace d to be equal to a. So d to be equal to minus 2. So we have x into 1 divided by 2 into minus 2 plus 4 e power minus 2x. So you have again denominator is 0, right? Differentiate, multiply x again, differentiate once again. So you will have 2d plus 4 differentiation is 2. e power minus 2x. Here we have non-zero denominator. So x square by 2 e power minus 2x is your pi2 value. Therefore, the solution is y is equal to cf plus pi1 minus pi2. Just because of minus a, I'm just putting minus of this pi2, right? So cf is c1 plus c2x e power minus 2x plus pi1. So pi1 is 1 by 16 e power 2x minus pi2 is x square by 2 e power minus 2x. This is your required solution. Is it clear? Okay, so we'll move on to fifth problem. Solve fifth problem. Solve d plus 2 d minus 1 whole cube of y is equal to e power x, right? So you can see it is a linear differential equation of constant coefficients, right? So they are given in factorized form, right? No problem. Of order 4. Okay. So we will be having this to be equal to, so d plus 2 d minus 1 whole cube of y. Okay. So this will be the general solution is y is equal to cf plus pi. So to find cf, it is very easy, right? So it is auxiliary equation is m plus 2 into m minus 1 whole cube is 0. Implies m is equal to minus 2 is one root and m is equal to 1 1 1, right? Because multiplicity, right? It is m minus 1 whole cube means we solve this, we will have 1 1 1, right? Okay, that means one distinct real root and three equal roots, right? So therefore your characteristic function is c1 e power minus 2x. For these three equal roots, c2 plus c3x plus c4x square into e power mx, right? Into e power 1x. This is your required cf, right? Okay, now we will find particular integral will be 1 divided by d plus 2 d minus 1 whole cube into e power x, right? What you have to do, replace d by a, right? Replace d by a, replace d by a. Here a is 1, right? E power ax, 1 into x. So this will be 1 divided by 0, right? Because 3 into 0 into e power x. That means denominator is 0. So multiply x and differentiate this denominator. Here you need to apply what? UV method, or you can take a single instead of writing d plus 2 d minus 1 whole cube. This is same as d plus 2 into what is a minus b whole cube, a cube minus 3a square b plus 3ab square minus b cube, right? This is the expansion of a minus b whole cube. Multiply this d inside, so you will have d power 4 minus 3d cube plus 3d square minus d. 1 plus 2 here, so we'll have 2d cube minus 6d square plus 6d minus 2. So add it up, you will have d power 4 minus d cube minus 3d square plus 5d minus 2, right? This you can also write like this. Right? Whatever may be, whatever you write, but if you put d is equal to 1 here, 1 minus 1 is 0, minus 3 plus 5 is 2, 2 minus 2 is 0, right? So instead of writing this, I'm going to write this as d power 4 minus d cube minus 3d square plus 5d minus 2 e power x. So that differentiation will be easy, or else you have to apply UV method. It's also easy only, e power x, right? So replace, multiply, here if you put d is equal to 1, we have 1 by 0 e power x, right? So multiply x and differentiate this denominator, it will be 4d cube minus 3d square minus 6d plus 5, right? Now you again replace d to be equal to 1 here. So x into 1 divided by 4 minus 3 minus 6 plus 5 e power x. So 4 into 1 divided by 4 minus 3 is 1. 1 minus 6 is minus 5. Minus 5 plus 5 is 0. Right? Again it is 0. So multiply x once again. Differentiate this, right? Because this is f dash of d. So differentiate once again. So 12d square minus 6d minus 6 e power x, right? So replace d to be equal to a, d to be equal to 1, right? E power 1x. So this will be x square into 1 divided by 12 into 1 minus 6 minus 6 e power x. Again it is 0, right? Because 12 minus 12 is 0 e power x. So let us call this as, this is your f double dash of d. So multiply x once again, x cube, differentiate this once again. So it will be 24d minus 6. 24d minus 6 e power 24d minus 6 e power x. So replace d to be equal to 1 again. So you'll have x cube 1 divided by 24 minus 6 e power x. This is non-zero, right? So x cube by 18, x cube by 18 e power x is your required particular integral. Is it clear? X cube by 18 is your required particular integral. X cube by 18 e power x. So I think you can do any problem from type 1 now on, right? So only thing is 1 divided by f of d into e power x. Therefore the general solution is equal to complementary function plus particular integral. C of is c1 e power minus 2x, c2 plus c3x plus c4x square e power x plus x cube by 18 e power x. So we have solved 6 problems in type 1, right? We will continue solving problems on type 1. Is there any doubt up to now? Okay, move on to next problem. The outbreak which value to take a out of 1 or a is you have to pick from here, right? E power ax, it is of the form e power ax. So in that case, a is 1. You have to pick a from the RHS, not from the roots. Here also you can see e power ax. The roots are minus 2 minus 2. But e power ax, a is 2, a is minus 2 for this problem. Here a is 3 by 2. Right? The roots are 3 by 2, 3 by 2. That is not the case. E power ax. So a is 3 by 2. Right? Here a is 1. E power ax. Here a is 4. Right? So we have to choose a from this e power ax. So replace t by a. We want to solve the problem. Solve d square d plus 1 whole square d square plus d plus 1 whole square of y is equal to e power x, right? So this is the what order? This is will be second, two, four, sixth order differential equation, right? Sixth order linear differential equation constant coefficient. So the general solution will be y is equal to cf plus pi. So your complementary function is the to find cf. So first you find auxiliary equation equal to 0. So m square m plus 1 whole square m square plus m plus 1 whole square is equal to 0, right? So what are the roots here? 0, 0, minus 1, minus 1. Here, what is the root here? Solve this equation, you will have, this is again twice, right? Is equal to minus b plus or minus square root of b square minus 4ac divided by 2 times a. So minus 1 plus or minus I root 3 by 2 twice, right? So we will get characteristic function now. So characteristic function is, so here we have two equal roots. So c1 plus c2x e power 0x. Again we have two equal roots. c3 plus c4x e power minus x. Here we have what? One pair of complex root repeated twice, right? Alpha plus or minus I beta twice, right? So in that case, what is your characteristic function? E power alpha x into we already c3 c4. So c5 plus c6x cos beta x plus c7 plus c8x sin beta x. This is a characteristic function, right? We have already written down, those all this, right? So you can see the previous class. If you have one pair of complex root, yes, two pairs of equal complex roots. So e power alpha x, c1 plus c2x cos beta x, c3 plus c4x sin beta x, right? Alpha plus or minus I beta, alpha plus or minus I beta. So we have two pairs of same roots, right? Equal roots. This is your characteristic function. This is your CF now, right? This is your CF. Now to find PI, so PI is 1 divided by d square, d plus 1 whole square, d square. This is the 8th order, right? It is not 6th because we have whole square here. So we'll have d power 4 into d square is d power 6. D power 8 is the 8th order linear differential equation constant coefficient. D square plus 1 whole square e power x, right? Now replace d to be equal to a, right? E power ax. So a is 1 here. So if we replace d to be equal to 1, thank God, it is not 0. If it is 0 means you have to differentiate this entire term. So it will be 1 divided by 1 into 1 plus 1 whole square, 1 plus 1 whole square to e power x. So 1 divided by, so 1 plus 1 is 2, 2 square is 4, 1 plus 1 plus 3 square is 9, e power x. So 1 by 36 e power x is your PI, right? 1 by 36 e power x is your PI. See, here alpha is, I got to write alpha and beta. Here alpha is minus 1 by 2, beta is root 3 by 2, right? Alpha is 1 by 2, beta is root 3 by 2x. This is your PI. So therefore, general solution is is equal to CF plus PI. So find this is your CF plus PI, add it up, you will get the required solution. Okay. On the 8th problem, solve d minus 1 d square minus 2d plus 2 of y is equal to e power x, right? This is a third order linear differential equation with constant coefficient, right? Okay, so the general solution is y is equal to cf plus pi. So to find cf, so first you equate auxiliary equation to 0. So we have m minus 1, m square minus 2m plus 2 is equal to 0. So m is equal to 1 is the one root. The other two roots are solution of this equation minus b plus r minus root of b square minus 4ac divided by 2 times a. So we will have this to be equal to 2 plus r minus root of 4 minus 8. So it will be minus 4 by 2. This is 2 plus r minus square root of 4i square by 2. 2 plus r minus 2i by 2. So 1 plus r minus I. So we will have one distinct root and one pair of complex root. So we will have CF to be equal to C1 e power 1x plus e power alpha x into cos beta x C1 C2 C3 sin beta x, right? Alpha r minus I beta e power alpha x c cos beta x plus some constant sin beta x. This was CF. Now to find pi, so 1 divided by d minus 1 into d square minus 2d plus 2 of e power x, right? So what we'll do is we'll multiply this entire term inside. So it will be d cube. If you multiply this entire term inside, what you will have? So d into this term is d cube minus 2d square plus 2d and multiply minus 1 with this. So we'll have minus d square plus 2d minus 2. So when you add it up, you will have d cube minus 3d square plus 4d minus 2 into e power x, right? So d cube minus 3d square. Cube d cube 3d square plus 4d minus 2. Now replace d to be equal to a. Replace d to be equal to a e power ax, right? A is 1 here. So this will be 1 divided by 1 minus 3 plus 4 minus 2 e power x. It is 0, right? 1 minus 3 is minus 2 plus 2 is 0 e power x. So multiply x and difference the denominator. So we will be 3d square minus 6d plus 4 e power x. So again you replace d to be equal to a is 1. So x into 1 divided by 3 minus 6 is minus 6 minus 3 plus 4 e power x, which is non-zero. So it will be x into e power x is the particular integral, right? So therefore the general solution is y is equal to cf plus pi. So cf is this, pi is this, right? Very easy thought. And stop here because denominator is non-zero, right? So we'll do on to 9th problem. So solve d cube minus d of y is equal to 2 times cos hx, right? So cos hx is e power cos h x, right? Cos h ax is e power ax plus e power minus ax by 2, right? If you have minus here, you will have sin h ax. Then a is 1 here, right? Cos h 1x. So e power x plus e power minus x divided by 2. These two will get cancelled. So e power x plus e power minus x is your RHS, right? So you will have PI1, PI2. So general solution is given by y is equal to CF plus PI1 plus PI2, right? PI1 is this, PI2 is this. Okay, to find CF, so what is your characteristic function? What is my characteristic function? Auxiliary equation is m square m cube minus m is equal to 0. So take m common, we will have m square is equal to 0. So we have m is equal to 0 is one root, m square is equal to 1, so m is equal to plus or minus 1. Therefore the roots are, all three roots are distinct, right? So roots are 0, 1, minus 1. That means what? All three are distinct roots. CF will be C1 e power m1x, C2 e power m2x, C3 e power m3x. This is your characteristic function. Now we will find PI1. So PI1 is 1 divided by d cube minus d e power x. So replace d to be equal to a. A is 1 here, right? E power ax. Okay. So 1 divided by 1 minus 1 into e power x, which is 0, which is 1 by 0 e power x, multiply x and differentiate this. So you will have 3d square minus 1 e power x. So again, to replace d to be equal to a, this 1 here, right? E power x. So we will have x into 1 by 3 minus 1 is 2 e power x. This is where PI1. Now you find PI2. So 1 divided by d cube minus d e power minus x. So replace d by a. So a is minus 1 here, right? E power ax. So 1 divided by minus 1 whole cube minus 1 e power minus x. So minus 1 is minus 2. So 1 by minus 2 e power x is your PI2. Therefore, general solution is y is equal to CF plus PI1 plus PI2. Just add it up all this, right? CF plus PI1 plus PI2. We need to add all this. Okay. Is it clear up to now? Okay. So I'll give you, we'll solve 10th problem. After that, I'll give you one more. Solve solve d square y by dx square minus 7 times dy by dx plus 6y is equal to e power 2x. Given that y is 0, then x is 0, right? So why it is given? It is given to find the values of arbitrary constant, right? It is given to find the value of arbitrary constant, but here we have only one initial condition. We need two initial condition to find two unknowns, right? Because we have two unknowns here when solving characteristic function. Just write it down. So therefore, the general solution is y is equal to CF plus PI. So first we will find CF, characteristic function. So the auxiliary equation is m square minus 7m plus 6 is equal to 0, right? Solve this equation, right? You will get roots to be equal to 1 and 6. Therefore, your characteristic function is C1 e power m1x, C2 e power m2x, right? Let us call this as 1. Now to find PI, so PI is 1 divided by d square minus 7d plus 6 e power 2x. Now replace d to be equal to a is 2 here, right? E power ax. 1 divided by 2 square is 4, 1 into 2 plus 6 e power 2x. So 4 minus 14 is minus 10, minus 10 plus 6 is minus 4. So minus 1 by 4 e power 2x is your partial integral. So therefore the solution is y is equal to CF plus PI. So C1 e power x, C2 e power 6x minus 1 by 4 e power 2x, right? We need two we need to know value of two unknowns, C1, C2, but we have only one initial condition, right? That means we can only able to find one constant, C1, C2. Let us keep other constant as it is. So y is 0 when x is 0. So y is 0 when x is 0. Right, I'm just putting x to be equal to 0 and y to be equal to 0. So we have C1 plus C2 minus 1 by 4, right? Minus 1 by 4. So C1 plus C2 is 1 by 4, or I can write C2 to be equal to 1 by 4 minus C1, right? 1 by 4 minus C1. Therefore, the solution is given by y is equal to C1 e power x, right? This is the solution, right? C1 plus C2 plus C2. So instead of C2, I can write 1 by 4 minus C1 e power 6x minus 1 by 4 e power 2 is the required solution, right? So I'll give you two notes. Those two notes are very, very important, right? As of now, is there any doubt? Okay, Sarah, is it clear now? Just now I've seen your comment, right? Is it clear, right? The first note is uh, 1 by d of capital X, right? This capital X is a function of x. This is same as integration of capital X dx, right? Where capital X is a function of x. A function of x, right? If you have 1 by dx means you have to integrate this x, right? Remember, d is differentiation, right? We already assumed that this capital D is d by dx. So we have 1 by d. That means this d inverse. And we know in both differentiation and integration are inverse of each other, right? Differentiation, integration, inverse of each other. So d inverse is what? Integration. So just find integration of x dx to find 1 by dx. Note 2 is 1 by d minus a of capital X, right? So here we have only d, here we have d minus a. This is e power ax into integration of capital X into e power minus ax dx, right? So remember these two notes, these are very important, right? So if you have 1 by dx, this note will be useful for all the types, right? Not only for type 1. What is type 1? RHS is e power ax, right? So this note 1 is, if you have 1 by d of some function, integrate that function. If you have 1 by d minus a of x term, you write like this, right? Okay. Super. So based on this note, we will do one problem. Based on this note, we will do one problem. Solve 11th problem, right? So solve d square y by dx square plus 3 times dy by dx plus 2y is equal to e power x, right? We have e power x, right? We have e power x. So we'll do this. This is a very important problem, or this is the only problem that is different from all other problem, right? Because we have e power x. If you have e power ax, the problem is very easy. But here we have e power e power ax. Okay. So first, the general solution is y is equal to cf plus pi, right? So to find a cf, to find the auxiliary equation, it is same as d square plus 3d plus 2 of y is equal to e power x, right? Both are same. Okay. So we have auxiliary equation to be equal to m square plus 3m plus 2 is equal to 0. Find the root. So we will have m is equal to minus b plus or minus root of b square minus 4ac divided by 2 times a. So this will be 9 minus 8 is 1. So minus 3 plus 1 by 2. Minus 3 minus 1 by 2. So minus 3 plus 1 is minus 2. Minus 2 by 2 is minus 1. It will be minus 4 by 2, which is minus 2. The roots are real and distinct. Therefore, your characteristic function is c1 e power minus x, c2 e power minus 2x, right? Okay, now comes a very important part. What is pi? 1 divided by d square plus 3d plus 2 e power x, right? E power x. Yes, now how to do this problem? We have only e power x is very easy, right? T plus t by a. But here we have e power x, right? So if you have like this, right, what you have to do is first you do the factorize this, right? The roots are minus 1 minus 2. That means this can be written as d plus 1 d plus 2 into e power x, right? Now you do the partial fraction for 1 by d plus 1 d plus 2, right? What you have to do is you have to do partial fraction for right? You have to do partial fraction for 1 divided by d plus 1 into d plus 2, right? That means 1 divided by d plus 1 into d plus 2 is equal to a by d plus 1 plus b by d plus 2. So find a and b. So multiply by d plus 1 d plus 2 throughout. So we will have 1 is equal to a into d plus 2 plus b into d plus 1, right? These are very easy that we already seen in the previous classes, right? So put d is equal to minus 2. So you will have 1 is equal to b into, this will be 0. So minus 2 plus 1, 2 plus 1. So the b value is minus 1, right? Put d is equal to minus 1. So we will have 1 is equal to a into minus 1 plus 2. B will be 0. So we will have a to be equal to 1, right? That means this can be written as a 1 by d plus 1. A is 1, b is minus 1, right? That means you just replace this as 1 by d plus 1 minus 1 by d plus 2 e power x, right? So this is 1 by d plus 1 e power x minus 1 by d plus 2 e power x, right? Okay. Let's call this as some I1 minus call this as I2. Now we'll find I1 and I2. So what is I1? I1 is 1 by d plus 1 e power x, right? Just compare with this 1 by d minus a of x is equal to e power ax integration of x into e power minus ax dx, right? So compare here we have a to be equal to minus 1, right? A to be equal to minus 1 by d minus of minus 1 e power x. This is what a is minus 1, right? E power minus x integration of this your capital X e power x into e power minus ax dx. Sir, no, just compare with this. Here a is minus 1, capital X is e power x, right? Now you have to integrate this. You have to integrate this. We have e power minus x integration of e power x e power this will be plus x, right? Because e power minus ax. So a is minus 1. So minus 1 minus will be plus e power x. Okay. Now what you have to do is, remember here this is unit, this is constant, right? Only thing is you have to integrate this term, not this term, right? Keep this term as it is. Now for integrating this term, what I'm going to do is, put t is equal to e power x. So dt will be e power x dx, right? Differentiation of e power x is e power x again. Will be integration of e power x is t, e power x dx is dt, right? E power x dx is dt. This is e power t. So this will be e power minus x. Integration of e power t is again e power t only. Now replace t by e power x. This is the value of I1. E power x into e power minus x is your I1 value. Similarly, you find I2. What is I2? 1 divided by t plus 2 e power x. So 1 divided by t minus of minus 2 e power x. The same as what? E power ax integration of x into e power minus ax, which will be plus 2x dx, right? So this will be e power minus 2x integration of, you have to integrate only this term, right? Even though it is a function of x, you take it outside and integrate this only. This is e power x. I'm going to write e power 2x as e power x dx. So put t is equal to e power x. So dt will be e power x dx. So this will be e power minus 2x integration of e power t. This is t, this is dt, right? So we have e power t dt. Now again you apply UV method here, right? UV minus integration of p du, because we have two functions, right? So you have to choose u to be ILATE. You have to choose u in this order, right? So I'll discuss this. So we have algebraic and exponential here. You have to choose algebraic to be first. So u is equal to t, right? dv is equal to t dt, e power t dt. Therefore du will be dt. V is integration of this is e power t. So replace here. This will be e power minus 2x uv, right? uv minus integration of v du. So e power minus 2x u into v. So u is t, v is e power t minus integration of v is e power t, du is dt. Will be e power minus 2x t e power t minus e power t. Now replace t to be equal to e power x. That will be the value of I2. So e power minus 2x e power x e power x minus e power x, right? This is your value of you can also take e power x outside, so that we will have e power. Okay, no problem, right? Let's take this. This is your I2 value. So therefore, what is your PI? PI is I1 minus I2, right? Partial integral is I1 minus I2. So I1 is this term, right? E power minus x, e power minus x, e power x minus I2 is e power minus 2x into e power x minus e power x, right? Therefore, general solution is given by y is equal to cf plus pi. So we know already cf c1 e power minus x plus c2 e power minus 2x, and this is your pi. Add it up to get the general solution, right? So if you have e power x means you have to do in this order, right? Is it clear? Type 1 is e power ax. So very easy type 1. So we will complete type 1, right? We will finish type 1 here. We will start type 2, right? Okay, is there any doubt in type 1? We will start type 2 now, right? So what is type 1? Type 1 is RHS is e power ax. So what you have to do? Very simple, find a CF. To find a PI, you just replace D by A. If the denominator is non-zero, that is the solution. If denominator is 0, multiply x and differentiate the denominator. That's it, right? Very, very easy. Okay. So we'll start type 2 now. So now we'll start type 2. RHS is sin AX or cos AX. Right? What is type 1? RHS is sin e power AX, right? So type 2 is RHS is sin AX or cos AX. RHS is sin AX or cos AX. Right? Sin AX or cos AX. So what is the general solution? General solution is given by y is equal to complementary function plus particular integral. Right? The method of finding CF is same. Right? Method of finding CF is same. How the question will be? So it will be dn a naught dn plus an dn minus 1 and so on up to an of y, an of y, an of y is equal to, we will have x. This x is sin ax or cos ax. Right? Sin in the previous type 1 we have e power ax, right? Remember this a is very important, right? You have to replace d by a, previous case, right? Okay. So here the method of finding the method of finding CF is same, right? That is, you need to find the auxiliary equation, find the roots, and then you find the complementary function. Now to find PI, right? To find PI, what is your PI? So 1 divided by f of t into, you will have sin ax or you will have cos ax, right? Sin ax or cos ax. The previous case, what we did, we have replaced d by a. This is your f of t, right? This is your f of t. This is your f of t, right? The previous case we have replaced d by a. So here what you have to do is replace d square is equal to minus of a square. So if you understand this single part, then you can do any problem, right? There we have to replace d by a. Here we have to replace d square by minus of a square and proceed, right? I will just write like this. The problem I will explain more, right? The problem I will explain more. What I did is, you just substitute d square is equal to minus a square and proceed, right? In the problem you will learn more, right? Because I don't want to confuse by writing the procedure for nth order, right? If I write the procedure for the nth order, it will be difficult. In exam point of view, we're going to get second order or third order, or in the worst case we'll have fourth order, right? So we'll do the problems directly so that you will have more clarity, right? So that you will have more clarity. Okay. Okay, so we'll start solving problems based on type 2. Solve d squared y by dx square plus dy by dx plus y is equal to sin 2x. This comes under what? This is not sin h2x. If it is sin h2x, means it is e power 2x minus e power minus 2x by 2, which comes under case 1, type 1. Now this is type 2. We have only sin 2x, right? So RHS is sin dx, or it can be cos ax also. A is 2 here, right? A is 2 here. So this comes under type 2, right? Okay, so we'll solve this. Solution is given by y is equal to CF plus PI, right? Now what is CF? Find CF. To find CF, right? So again, same procedure. Find the auxiliary equation, which is m square. This is same as what? D square plus d plus 1 of y equal to sin 2x. Right? Both are same. Okay, it will be m square plus m plus 1 is equal to 0. So m is equal to minus b plus or minus root of b square minus 4ac divided by 2 times a. So minus 1 plus or minus I square into 3 by 2, right? We will have minus 3. So this will be minus 1 plus or minus I root 3 by 2 is of the form alpha plus or minus I beta. So we have one pair of complex root. CF is e power alpha x C1 cos beta x plus C2 sin beta x. Right? This is your CF. We are coming to a very important part. To find PI. Right? To find PI. What is PI? 1 divided by f of d, which is d square plus d plus 1 sin 2x. Right? Now, if you have type 1 means replace t by a. And if denominator is non-zero means that is the partial integral. If denominator is 0 means multiply x and differentiate denominator and proceed. Right? Here what you have to do? Replace d square by minus a square. Remember, minus is outside this. Right? So we should always have d square to be minus of some term, which will always be negative. D square will always be negative because a square is always positive. So minus of the term will always be negative. Right? This means minus of, what is a here? Sin ax. Sin, compare with sin ax, right? Sin ax. So a is 2, right? So that means replace d square to be equal to minus 4. After replacing this, we will have d square to be minus 4, 1 by d plus 1 sin 2x, right? Okay. Here we will have 1 divided by d minus 3 sin 2x, right? Sin 2x. Now you can do the previous method. That is, you can use the note, right? What note says 1 by d minus a of capital X is this. What this note says, right? 1 by d minus a of capital X is. You can use this formula, but I'll tell you the another method, right? This will be very easy. What you do is you just multiply this with conjugate, right? So d plus 3 divided by d minus 3 d plus 3 sin 2x. Right? What I have did? I have replaced d square by minus of a square. So we should, if it is second order means, right? We have d minus 3 here. If you have d minus 3 here or some whatever term you have in this pattern, right? Multiply with its conjugate. So this will be d plus 3 divided by a plus b, a minus b. It is a square minus b square of sin 2x. Is it clear? Whenever you have some pattern like this, d minus a or d plus a is 3 here, right? Or see d minus alpha, d plus alpha. That means we have this will be equal to this what? D plus 3 divided by d square minus 9 of sin 2x, right? And we know d square is minus 4, right? So whenever you find d square, substitute that to be minus 4. We have substituted minus 4 here. So we have got d minus 3. Multiply by its conjugate. So we have this term. Again you replace d to be minus 4. So we have minus 4 minus 9 of sin 2x. Right? So we have minus 1 by 13 d plus 3 of sin 2x. Now multiply this inside. So d of sin 2x plus 3 into sin 2x. Right? D of sin 2x plus 3 into sin 2x. And we know d is differentiation, right? D is d by dx. What is differentiation of sin 2x? It is cos 2x into 2, right? Plus 3 times sin 2x. This is your required particular integral. Minus 1 by 13, 2 times cos 2x plus 3 times sin 2x is your required particular integral. Is it clear? That is what I don't want to confuse here, right? And proceed. I just written and proceed. If you have some terms like d minus alpha, right? D minus alpha is 3 here. Multiply by its conjugate and they multiply this d plus 3 to this term. So d of sin, that means you have differentiated sin to x. The 3 times this term will remain as it is. And the new denominator, you replace d square to be minus 4. You will get the answer very, very easily. Right? Okay. So therefore, general solution is y is equal to CF plus PI. Substitute CF and PI values. Right, CF is this e power minus x by 2 c1 cos root 3 by 2x plus c2 sin root 3 by 2x, and the c2 is minus 1, sorry, and the particular level is minus 1 by 13, 2 times cos 2x plus 3 times sin 2. Okay, move on to second problem. So solve b square minus 5d plus 6 of y is equal to sin 3x, right? Sin 3x. So now we'll solve this problem now. Any doubt up to now? There are many problems here. I don't know which problem to pick. Okay, so we'll do this and then we will problem to do next. Okay, so I'll do it fast. The general solution is y is equal to CF plus PI. So we will find CF, right? So to find CF, find the auxiliary equation, which is m square minus 5m, which is m square minus 5m plus 6 equal to 0. Solve this, we will get 2 comma 3 as the root. Therefore, CF is C1 e power 2x plus C2 e power 3x, right? Now to find PI, so PI is 1 divided by d square minus 5d plus 6 into sine 3x. So here sine ax, right? So replace d square to be minus of a square minus of d square. So it is minus 9, right? Remember, it is always be negative. So replace d square by minus 9. We will have minus 9 plus 5d plus 6 sin 3x. So 1 divided by 5d, minus 9 plus 6 is minus 3 sin 3x. So take conjugate here. So we have 5d minus 3, right? So multiply with its conjugate, 5d plus 3, 5d plus 3 sin 3x. So 5d plus 3 of sin 3x divided by a minus b, a plus b. So it is a square minus b square, right? So we square this, we have 25d square minus 3 square. So 5 times differentiation of sin 3x plus 3 times sin 3x divided by, so 25 into d square is minus 9, right? So this will be 5 times differentiation of sin 3x is cos 3x into 3 plus 3 times sin 3x divided by, so 25 into minus 9. So it will be minus 225 minus 9, right? So it will be minus 234 AD plus 3. So the question is minus. Okay, so we change question to plus, right? So we change the question to plus, no problem. So this will be the required PI, right? This is a required PI. So if it is plus, means root will change, right? Okay, question is minus here, but I written a plus here. So it will be minus minus 5d minus 3. Minus 5d minus 3, right? It is minus outside. So we will have 5d plus 3 multiplied by its conjugate, 5d minus 3, 5d minus 3 sin 3x. So rest it is minus outside as it is. So 5 times differentiation of sin 3x minus 3 times sin 3x divided by a plus b, a minus b, right? So it will be 25 d square minus 9. So this will be minus of 5 times and this will be cos 3x to 3 minus 3 times sin 3x divided by d square is minus 9, right? So this will be 5 3s are 15, so 15 cos 3x okay, it will be 15 cos 3x 15 cos 3x minus 3 times sin 3x divided by 3 minus 2 34, right? Yes, get cancelled. It's your PI, so therefore the general solution is, if you want you can also take some terms common, you can cancel with 3 tables. General solution is y is equal to CF plus PI. So CF is this, PI is this, add it up to get the required solution. Right? Okay, so we'll stop here. Right, in the next class we will continue solving problems based on type 2. Right, we're going to continue solving problems based on type 2 from in the next class, right? So the class we will finish type 2 and we will start type 3 also in the next class, right? We'll just recall what we did. So in the very beginning we have introduced what is meant by type 1, that is where RHS is e power ax, so you have to replace d by a, and type 2 is sin ax or cos ax. So as of now we have did only 2 problems. We will do more problems on type 2 in the upcoming classes, right? So thank you, all the best.